So let me give an example now. To find the Mobius transformation that transforms the three distinct points -1, 0, 1 onto the points -I, 1 and I respectively. That means -1 is transformed to -I, 0 is transformed to 1 and 1 is transformed to I. So what is that Mobius transformation? So we know that the unique Mobius transformation that maps distinct points z1, z2 and z3 onto three distinct points w1, w2 and w3 respectively is given by the preservation of the cross ratios. That means w minus w1, w2 minus w3, w minus w3, w2 minus w1, and that is equal to z minus z1, z2 minus z3, z minus z3 and z2 minus z1. So in this case, so we here what we have, your z1 is equal to -1, z2 equal to 0 and z3 equal to 1. Okay, and your w1 equal to -I, w2 equal to 1 and your w3 equal to I. So thus we have, so w minus w1 is minus I, so it is plus I, then w2 is 1 minus w3 is I, and this is w minus w3 is I, then w2 is 1 and this is w1 is minus I, so it is plus I. Okay, and that is equal to, so it is z minus z1, so it is plus 1, then 0 minus 1 because z2 is 0, z3 is 1, then z minus 1 because z3 is this, and 0 minus 1, so it is plus 1. Okay, so you can actually simplify it. You just multiply this by the conjugate of this, so I'll get that this is 1 minus I square 2, so it is 2 times of w minus I, and this is 1 minus I whole square, and that I will get minus twice I, so it is minus twice I w plus I. Okay, and that is so it is minus 1, so it is z plus 1, and I can say 1 minus z, right? Or this it is cancelled out, so I can say that minus 1 is cancelled out, so you can simplify it as I w plus I and w minus I, 2 cancelled out, and 1 minus is also here, I can adjust here, so it is z minus 1, right? So you have that this is IW minus 1 and this is W minus I, and that is equal to Z plus 1 and Z minus 1. So you need to solve this in terms of, so this is the Mobius transformation, but if you write in the standard form, then you can simplify it. So it is IW minus 1, or you can use component 2 and dividend 2. Alright, so or you can just simplify it because it is very easy. Alright, so it is nothing but IWZ minus IW minus Z plus 1, and this is ZW, then minus IZ plus W minus I. Okay, so I need to solve in terms of W. So how many WZs are there? So if I transform this, 1 minus IWZ. Okay, and here your what is your W? So W will be minus I and minus 1, so it is plus, so minus I plus 1 W, and if you take z's on that side, so you will see that this is 1 minus I z and minus I minus 1. Okay, so you can actually then you consider W, and that will imply if you solve this, then you will see that your W equal to nothing but some Iz, then plus 1 and minus Iz and plus 1, and that I can multiply by minus Iz, then minus Iz, this one, if after simplifying. Okay, so after simplifying you will see this, and you multiply both sides by say I. So if I multiply by I, so it is I minus Z, and if I multiply by I, so it is I plus Z. So this is the Mobius transforms. So this is the required Mobius transformation that transforms the 3 points minus 1 0 1 and minus I 1 I. Okay, so next in the next example I will show I will take the point at infinity.